Now, since we only have one sensor, we're gonna do only one if statement. So this is the if statement. We're gonna check um, whether our default is gonna be smaller than our what we're reading at the value. Because we're constantly calibrating the sensor, default changes in value, but the closer you get to the center or close to the board, the less drastic those changes will be. So there will be reach a point where even though the default's been changing, getting smaller as well, center sensor value will still trigger the robot to act. Now, here we kind of want to give you a chance to be able to pull away your hand. So we're gonna have one variable, and what this variable is gonna be called is quick, and this is gonna add like a sense of randomness to our code. Yeah, and in that spirit, we're using this function called random. So random, you feed it two numbers. You feed it one number, so in this case 800, and then 2500, and it's gonna pick a number between those two numbers. So any number between them, uh, and it's what we're gonna use that is we're gonna use that to again add some sense of randomness to our robot. We're gonna check whether quick this amount of time has passed, and then if it has, we're gonna react. If it has not, then the robot won't do anything yet. So what this is gonna do is this is gonna make it so that you might be able to get closer to the board, and then you can pull your hand back um, if you're fast enough. Otherwise, it's gonna catch you. So we want to indicate that the board basically um, is there, that it's gonna close. So because we're already using the LEDs or something else to indicate how close you are, we're gonna use a tone, and we're gonna play it for an 8 note basically. Now, because the way the robot is built, it requires a bit of force to move it. We're gonna have our motors move clockwise, so we're gonna connect it to M2. If you want to change it to M1, you can. But we're gonna make it spin clockwise, and we're gonna make it do it at a pretty strong speed of 100. And then we're gonna delay for 1 second. And the reason why we're doing this is we're giving it like time to start closing. So like in physics, an object in motion wants to stay in motion. So we're gonna start fast, and then since we already kind of started the movement, now we can slow down a little bit to a more to a smaller speed. And the reason why we do this is we don't want to force the motor to keep trying to close the hands at a speed of 100, because then you can spin your motors too quickly and damage them. So this is just kind of to release some of the stress from having them close. So the motor will be spinning, trying to spin, but it won't because it can't go any further. So yeah, it releases stress. And then after that time has happened, we want to go back to the initial position. So we're going to go the opposite direction. But unlike the first one, we don't want to do this for too long. We just want to kind of reset the hands back to the original position. So we're going to set a fairly small delay. It's just kind of to open its hands quickly. And then after this is done, we're going to tell the motors to stop, or in this case loose. So we don't want to lock up the motors, and the speed doesn't really matter, but because this expects 3 things: which motor, what action, and a speed, we're gonna feed it to it. And the last thing we're gonna do is afterwards we're gonna play like a little tone so that we know that it's open, that it's happened. So tones that it's closing, and 2 tones that it's open. Alright, so that concludes the motion capture video. Hope you like this. Please like and subscribe, and hope to see you next time.